Right, so this is pure 2 chapter 7. Moving on from another trigonometry chapter. Previously, you have learned in chapter 5 about radians, which is still, about trig. And then you have learned chapter 6 about reciprocal and inverse function of trig. And chapter 7, still trig. Yes. You're going to learn some new formulae, identities. Identities, yes, you learn, yes, still more. And then the second part, which is more importantly about modeling. So the whole chapter 7, you can break it down into 7.1, 7.4, which is about new identities, new formulae, and then 7.5 onwards about modeling. Modeling, you will see it nearly every single year, at least one per year. Okay, so and usually carry quite a bit of marks, well, like 8 to 10 marks. So yes, so let's have a go about learning new formulae. Why not? First thing, here's the start of the question. If you've got the notes with you, then you can do it in your notes. If you don't, you can just have a look at the question here, do it on a piece of paper. So question 1, and then question 2, pause the video, have a go at the question. Okay, when you're ready for the answer, you can press play. Right, so question 1, the answer is, first of all, you have to do an inverse trig, or now we've learned technical term, which is called the arc sine of negative 0.9. As soon as you do arc sine in calculator, you should be using a cast diagram, or you've used a formula, 180 degree plus and minus thing, then use that. I don't normally remember the formula because, my memory is quite limited. I've got goldfish memory. If I put too many things in there, I'll forget something more important, like what I want to eat tonight. So yes, there's no place for this, silly knowledge. Silly knowledge is the formula. Anyway, so if I recall using cast diagram, I can use it every time. So inverse sine, I got negative 64.2. So I go in the negative angle direction, and then to work on the actual answer, which belongs to the range of 0 to 360 degrees, I'll go in the clockwise direction. So 180 plus 64.2, that answer, and then 360 minus that. Then you do minus 50. One common mistake students make is they take away 50, so they use 194.2, then they use cast diagram, which is obviously wrong. So if you use the cast diagram or the formula straight after you do the arc sine or arc cos or arc tan. All right. Question B. Hopefully you should see this as a quadratic function. Sin x is your variable, y squared, and then you use a quadratic function to calculate to solve the correct formula, a quadratic equation. Sorry. And sin x, you get 1.5, and sin x equals -1. As we all know, sin quite temperamental. Sin is only bound between -1 and 1. Anything outside of that range, sin x won't have it. Okay. Right. So sin x equals -1. We know sin x equals -1. Put in the calculator, 270 degrees. We also know there's only one answer because of a sine graph. So a trick for you is whenever you have to solve any equation about sine and cos with -1 and 1, I will use the graph, because then I can easily tell how many solutions are there and not mixing up with the other. With -1 and 1, you can't reuse the cast diagram in the formula because it doesn't quite work that way. Question 2, to prove means you want to choose one side to start with and then move to the other side. So here I start from left-hand side because there's more things to work with. First thing I did was to make a tan x into sin x over cos x. With proof question, the way to learn it is not just copying the answer, but it's more about asking yourself, why do I do it this way, or why does the teacher do it that way? What's the thinking logic behind it? So the first step I did was to make tan x into sin x over cos x. Well, why? Why do I make it into something about cot x? Because cot is reciprocal function. In the right hand side has a reciprocal function. So do we not use cot x? The answer is no, because we can see cos x and sin x in the front. So making tan x into sine over cos does make sense. So we can do some simplification in there. All right. So yes, that's the reason why. So a blue arrow in here just to sort of tell you. So if you want to make some notes on why, so the reason is there's cos x and sin x. So why not cos x? So that kind of stuff. These are notes that that's personal, that I can't teach. So every single step you want to make some small notes in between, like why, right? Then I simplify the fraction, and then these two fractions, add them together, have a common denominator. A numerator, cos squared plus sine squared, is 1, and 1 over cos x is sec x. Right? Part B, left hand side, start with left hand side again, and cos squared plus sine squared is 1. denominator, 1 plus cot squared is cosec squared. You have learned in previous chapter 6, and 1 over cosec squared is sine squared. So a simple question like this actually tests you the identities you've learned and also about reciprocal. So, you know, it looks simple, but you have to recall a bit of knowledge. All right, so left hand side equals right hand side. Quite a smooth direction of steps. Next, the new formulae. You're going to learn 6 new formulae, but they combine them into 3 because there's a plus and minus version. They are shown in the formula booklet. So, right, but they're showing this format, which I'm going to show you as well. So the first one is known as sine A plus or minus B, which equals to sine A cos B plus and minus sine B cos A. So what do we mean plus and minus? What it means is, if we want to use plus A plus B, sine A plus B, then we can use sine A cos B plus sine B cos A. If we want to do sine A minus B, then we can do sine A cos B minus sine B cos A. For cos, we'll do A plus and minus B, which equal to cos A cos B minus plus sine A sine B. 2 differences in here. The first difference is we put cos first, cos A cos B, compared to sine with sine A cos B, we do cos cos, sine sine. Second difference is plus and minus in here becomes minus and plus. In other words, if I want to do cos A plus B, that equals to cos A cos B minus sine A sine B. If I want to do cos A minus B, that equals to cos A cos B plus sine A sine B. And last but not least, the tan. Tan A plus and minus B equals to tan A plus and minus tan B over 1 minus plus tan A tan B. Well, yeah, so quite self-explanatory. With tan A plus B, we do tan A plus tan B and 1 minus tan A tan B. So if you're going upper root, then we follow upper sign. If we're going to go for the bottom root, we follow the bottom sign. Wondering why is it plus and minus on the top and minus and plus in the bottom? Well, think about this. Now, what does tan A, tan equals to? Tan also equals to sine over cos. So tan, not unofficially, but officially, not on the formula booklet, but tan A plus minus B also equals to sine A plus or minus B over cos A plus and minus B. I'll suggest you write down, okay? Also equals that. And think about this. If you've got cos in the denominator, remember plus and minus for cos is minus and plus. Therefore, that's a minus and plus. Okay? So these are all given. So these are all given in the formula booklet. If you show this FB to your parents or anything a bit older than 30 years old or anything about, you know, older people, then they'll be thinking FB, Facebook. What do you mean by that? Anyway, I'm one of them using Facebook. But yes, you know, that's the cool thing when we grow up. You know, that's the first social media that went viral. Anyway, I was going to say Facebook. No, formula booklet. Given a formula booklet. Next example. So I would like you to have these formula next to you so you can refer to them. Okay. Example. Express the following as a single sine, cosine, or tangent. Question A. Sine 15 degree cos 20 plus cos 15 sine 20. Now I would like you to think about which one does it relate to. Okay. Which one does it relate to? Well, you can see sine, cos, that's going to be same as this one, the sine A plus minus B. So part A, we know as something to do with sine A plus B. Your A is 15 and your B is 20. So therefore, the answer to question A would be equals to sine 15 plus 20 degree, which is sine 35 degree. Okay. One thing is you can put in a calculator, check your answer. You can put the whole thing, sine 15 cos 20, just plug it in, make sure your calculation in degrees, and then equal, and then compare with sine 35 degree, you should get the same answer. Whereas if you try to expand the bracket, now that's technically wrong, and I feel foul for saying this. If you try to expand the bracket and say sine 15 plus sine 20 degree, try putting it in a calculator, you realize that's not the same answer as sine 35. I suggest you have a calculator and verify that, check it. Okay, you realize that's not the same. You can't do that. You can never expand the bracket because that's not a bracket you want to expand. It's not like a simple algebra, right? So hence we have to use a formula. Okay, if it's that simple, then we don't need a formula. Why do we need a formula? Right. So part E, or question B, compare this with the previous one. Okay, which one does it relate to? Cos, sin is about the cos A plus or minus B. So question E, cos, sin, but because of a plus in the middle, we have to do the minus, we have to do the negative in the bracket. So it's the opposite sign in the bracket. So that equals to cos A minus B. Your A is sine 2 theta and your B is theta. So that equals to cos 2 theta minus theta, which is same as cos theta. That's the answer, right? Next, example and practice. Now I say example because I will need to show you the skill how to do this, but it's all practice because you can come back to it later and try to have a go at this question. Now, in order to prove 10a plus d is this formula, this is the question, it's a 4 marks. There are not a lot of steps, but you'll need to be shown the steps before you have the idea how to do it later on, okay? Right, so starting from a formula, sin a plus b and cos a plus b, prove there's 10a plus b equals 10a plus 10b over 1 minus 10a 10b. Right, so I'll give you maybe 5 seconds to think about which side do we start, left-hand side or the right-hand side? We will start on the left-hand side. Well, why? Aren't there more stuff, more terms to work with on the right-hand side? The hint lies in the question. It says sin a plus b cos a plus b. That's the same as the left-hand side. So something related to left-hand side. So therefore, we're going to start from the left-hand side. So left-hand side equals 10a plus b. As I've said, 10a plus b is the same as sin a plus b over cos a plus b. Next, the question also tells you to use the formula for sin a plus b. Can you remember, can you recall the formula without looking at them at the previous page? If you can, good job. If you can't, try to remember them, right? So sin a plus b equals sin a cos b plus sin b cos a. Now remember, I use my memory very, very stingily. I don't know. I've got very stingy memory, so I don't want to recall something that is not important. For example, what I want to eat for dinner. So if I take the effort to remember it, that means it's important enough over than what you want to eat over the dinner. For denominator, so cos A cos B minus sin A sin B. Next, now, okay, so it's pretty straightforward from here what we've done. Next, I would like you to compare what we've got to right hand side, what's common and what's different. Okay, so pause the video, think about this. What's common and what's different? And when you're ready, you can press play. Well, let's start from positive, shall we? Like in our lives, sometimes we want to be grateful for what we have. Oh, by the way, have you heard about some people do, if every day you start with thinking about 3 things that you're grateful for, you start the day about this, even the small things like, okay, I'm thankful of, I've got a warmer, I've got a heater next to me when I wake up in the winter, something that's small. Every day has to be different. Then you are more likely to have a good day because you're more aware of things around you, positive things around you. It's particularly important if you have a bad day. That really works. So positive, well, it's quite forceful, but both is a fraction, isn't it? They're small things. They're both is a fraction, weren't they? So they're both fraction. Second thing they're common is there's positive on the top, negative in the bottom. And the third thing that positive is that there are 4 terms. All of them has 4 terms. 1, 2, 3, 4, same as 1, 2, 3, 4. Now what you realize is then you will be thinking next is, does this bottom left term 1 same as cos A cos B? That means somehow we should change the cos A cos B into 1. Well, if that what you're thinking, then you're correct. We try to make this cos A cos B into 1. Okay, so that will be our thinking point. So how do we do that? Well, why don't we divide that whole thing by cos A cos B? But to make it fair, if you divide this term by cos A cos B, you have to do it to the other terms as well, right? So make it fair. So otherwise the other algebra will cry. So you divide every single term by cos A cos B. Right? So that's a trick. All right. Trigonometry. Anyway, yep. So first term, sine A cos B over cos A cos B. I said divide every single term by cos A cos B plus sine B cos A over cos A cos B over bottom left cos A cos B over cos A cos B. Second term as bottom right corner sine A sine B over cos A cos B. Next, this is where the magic happens. If only Disneyland sponsors me with this video. Okay, this is where the magic happens. Okay, let's have a look. So bottom left corner, we know the term cos A cos B make it into 1 anyway, so that works for us. Now, what about the rest of them? It actually falls into place very, very nicely. Top left, cos B, they cancel out. Sine A, cos A, that will be 10A. Second term, top right, cos A cancel out. But this sine B, cos B, it will make it into 10B. Bottom right, sine A, cos A, 10A. Sine B, cos B, 10B. So our next step is actual final answer, which is top left, 10A, top right, 10B, bottom left, 1, bottom right, 10A, 10B. You finish it off with equals to right-hand side. Done. All right. So that's what I'm saying. You have to be exposed. You have to be shown with this method. Right. Now, hopefully you do remember next time when you see this question. All right. There's the only way to work it out. All right. I believe that's the end of chapter 7.1. That is the end of chapter 7.1.